Hello dear students, a very good afternoon to all of you. Thank you once again to join this session. We are in the last day of our robotics series. The series name was Master Arduino Like a Pro. And so far we have completed 5 days with 5 different projects, and today we are gonna use all the things that we have learned so far and create one complete project. Okay, I hope that you all are excited and you got a lot of learnings from this series. Well, for those people who are completely new to this series, let me introduce myself to you. My name is Ahmad Sheikh. I have 12 plus years of experience in teaching and training, with over training of around students 1.2 lakh all across the globe. I am a senior master teacher at sisyaclass and I hold subject expertise in coding and robotics. Well, I would really like to invite you and welcome you to sisyaclass. Thank you so much for joining this session. Make sure that you visit our website to know more about the courses that we offer to all of you. sisyaclass provides affordable and top quality education for various subjects. So make sure that you visit the website and see all the courses that we offer. If you have any questions, you can drop the query in the website so that we can get back to you as well. Well, here is the timeline that we were following. So far in the series of these 6 videos, we have completed 5 videos completely. Now the thing is that we are at the end of this series. Today's topic is motion activated cooling system for pets, and this project can be useful for people who have pets at their home. A very useful project, especially to maintain the temperature of the environment where your pet is actually living, especially in this summer times where the temperature is rising very significantly. It can be a very good project if you have a pet at your home and you have some plans to leave your pet at home and go somewhere else for a trip, for a 1 or 2 day trip. So this project will make sure that your pet is always in a very well controlled temperature, and he might not face a difficulty in staying with very extreme temperature, either too hot or too cold, right? So I believe that this is all clear to you and you are super excited for working with this project along with me. If it is possible for you to sit along with me and follow all the steps that I am showing, you can create the project along with me as well. Okay, so fine, here is the agenda for today's session. Okay, this is how our project is going to look like, and if you have followed our previous videos, you might see that we have worked on all of these components one at a time in each project. Now it's the time that we will combine all the components together and we'll create a complete complex project, okay, which will solve a real life problem. Okay, so that's our agenda for today's session. Point number 1 that we are going to do is revision of what we have learned so far. Everything that we have learned and everything that we are gonna use from the previous session is something that we are gonna revise once again. Okay, and once the revision part of it is done, next we will be moving to the creating of the project which is displayed over here. Okay, and finally we'll have some quiz question which will check that how much you have understood in the span of this 6-day session. Okay, well, don't forget to share your love by hitting the like button and sharing it with your friends so that the people who might need this information will use it to the best of their capacity. Alright, so without ado, let's get started. Fine, so the very first thing that we're going to talk about is about Arduino pins. Okay, we had understood that Arduino is a board that we can use to interface with different sensors and actuators, right? Now sensors can be considered as input components. Now these input components will sense something from the environment and give that output, and this output from the sensor will basically be used as an input for the Arduino board. Okay, now based on this value, the Arduino can be programmed in a way that it can take certain decisions based on what value it is getting. The same thing we have done yesterday also, where we put a condition for a temperature, and when the temperature rises to a certain level is when the motor turns on, right? So this is how we can make programs for making controlled decisions in Arduino board. Okay, so when we talk about communication between several components, the way that the electricity is passed or the signal is passed depends upon what kind of component we are using, and based on that we have two different types of pin when it comes to signal processing. The first one is digital signals, and for digital signals we have digital pins, and the second one is analog signal, and to control that we have analog pins. So again I am repeating once more that we have two different types of pin, digital and analog. Analog pins are used to handle analog signals, digital pins are used for digital pins. I hope so this is really very clear to all of you. Okay, now moving ahead, we also understood that what digital pins are. Now the wave for a digital pin can be represented by a square wave. Now in this square wave, if you see, all the lines which are in the bottom represents bit value 0, and all the values which are above can be considered as bit value 1. So we have 0 1 0 1 0 1 0, and if you look at the bit stream, the bit stream will be over here like this: 0 1 0 1 0 1 0. This is the bit stream. So basically if we want to pass this bit stream is when we will be sending this square wave. I hope so this is clear, right? So there is no in between value, either it is off or it is on, either it is 0 or it is 1. Okay, so there is no in between value. So whenever we want to interface with these kind of stuff is when we will be using digital pins. However, there is a special case in digital pin as well. If you remember, the special case was PWM, which stands for pulse width modulation. In pulse width modulation, it's a special kind of digital signal which sends a stream of bits to the component, and then the component can understand what it is actually supposed to do, like the way that we have interfaced the servo motor in day 5. Okay, so this is the difference between digital pins and analog. Now coming to the analog signals, if we want a value to be anywhere between a maximum and a minimum value is where we are saying that we will be using analog signals. And when we use analog signals to interface it with the Arduino board, we will be using analog pins. So analog pins are actually used for interfacing with analog input as well as output. Okay, the minimum value over here is 0 and the maximum value for Arduino Uno is 5. However, this can vary for different kinds of board and different versions of board that you can work around with. Okay, so we understood two types of pins, digital pins and analog pins. Then the third type of pin was power pins. Now when we talk about power pins, we have three types of power pin. One is 3.3 volt supply, then the other one is 5 volt power supply, and the third one is the ground. Ground can also be considered as a drain, where all the current will end up over there, leading to completion of the circuit. Until and unless the circuit is not completed, the current will not move, and if the current is not moving, then we will say that the component will not work at all, and ultimately your project will not be functional. Okay, so this is how the Arduino pins actually work. 3 pins that we need to remember over here, and 1 plus. When we learn about digital pin, we should always understand about pulse width modulation as well. Okay, so with this we are clear with the pins part. Okay, I believe this is clear, and if you have any questions or any concerns, you can drop it in the chat section so that I can address them in the live session itself. Okay, moving ahead to the next part. Then the next thing is reading and writing to Arduino. Now a lot of people get very confused at when to use read and when to use write, and when are we getting input and when we are getting output. So for me, what I do is I tell all of my students, and this makes things very easy for them, that whenever you're considering input or output, you look at the board. So if you have the Arduino board, you ask yourself this question, whether the current will come from an external source inside the board or from the board it will go to an external source, right? And based on that you can consider whether that pin will work as an input or an output pin. I hope this is clear, right? So we have board. If we want to turn on an LED, let's see that we have an LED, right? So from the board the current will go to the LED, it will make the LED glow, and then the current will come back. Because the current was going from the board to the LED, then that pin will be considered as output. Okay, so this is sometimes a bit confusing, because you know what, if let's say that if we have one LED over here connected, right? So, and let's say that we have a digital pin connected with a positive end, and negative end is connected to the ground, right? Now the output from the Arduino board is actually input for the LED, right? I hope so this is clear, right? And therefore people really get confused at what should we write over here. Should we make this pin as input or output? So always your reference, your point of reference should be from the Arduino board and not from the component. So you see, from the Arduino board, is the current getting out or are we getting the current? So in this case, in case of the LED light, we are sending out the current, and therefore this pin will be considered as output pin. Okay, moving ahead to the next point is the PIR sensor. So if we have the PIR sensor, we'll have this power pins, power pin and ground pin, and then we have signals. Signal can be connected to what? To any digital pin. Okay, now we'll see that where this current is coming from. Okay, in case of this signal pin, the current is moving from the sensor to the board. Now what will this be? Whether this will be input or output. So see, understand this. This signal is actually an output signal for the sensor, but it is input signal for the Arduino. So the output of the sensor will be the input of the board, and therefore what we can say is that this pin should be considered as an input pin, because the reference that we will be using to determine whether the pin is input or output will always be from the Arduino board and not from the external component. I hope so this is clear to all of you, right? This is a place where most of the students get confused, and they end up, you know, setting the pin mode of different pins oppositely, and then their project don't work at all. So always keep this in mind, that if you want to determine that what kind of pin mode you are supposed to set to a certain pin, you will check whether the current is coming inside that pin or going outside that pin. Okay, now based on that we'll have read and write. So when we do the programming aspect of it, we do the programming part of it. If we want to send out a current, we will always use the function called write, and if you want to receive some current or receive some signal, the function that we will be using is read. Now depending upon what kind of signal you are using, it can be either analog or digital, the function name will change, right? For example, if you want to read something and the reading part is done using the digital signal, then here you will write digital write. It will be digital write and then the bracket. However, if you are doing the same thing but using an analog pin, then in that case your function name will be analog and then write, open close bracket, right? So the thing is really very simple. If you want to send out a signal from the board, then you will say write, and if you want to receive something, then you will say read. Then what kind of signal are we talking about? If it is analog, so we have analog write, analog read, and if it is digital, then we have digital write, digital read. I hope so this is clear. Okay, fine. So two types of signals that we have and two types of functions that we have. Okay, let's not get too much confused, because we are going to use this extensively in our project in today's session. Okay, let's move ahead. So here are the components that we are going to use in today's session. Okay, so the idea of our project is that we want to create a project which will see if the temperature of the environment is suitable for your pet or not. Okay, now if the temperature, the environment temperature exceeds a certain threshold, then it will check whether the animal or whether the pet is in the surrounding or not using motion sensor. And if the animal or the pet is in front of the sensor, is when the I would say the fan will turn on, leading it to the cooling of the room. or the place for proper ventilation. Okay, so this is the idea. Now the thing is, why are we doing this? Why are we checking two conditions? The two conditions are, first, that the temperature should exceed a certain level, second, that the pet should be there, right? So see, if the pet is not there and the temperature exceed to a certain level, what will happen is the fan will turn on, but it will be useless because there is no one over there, right? So this will be this is wastage of electricity. So we want to make sure that wastage of electricity is also not there. Okay, on top of that, if let's say that if the temperature is low but still there is someone, we don't want to turn the fan on to lower the temperature even more, because that might again lead to some problem to the pet, right? We want a controlled temperature in that environment or in that room, right? And therefore checking two things becomes really very important. Okay, one is the temperature and the second is the presence of the pet. If these two things are beyond the critical range is when the fan will turn on. Now based on the fan is turned on or not, we want to show an indication using an LED whether the fan is on or off. So if the temperature is fine and the fan is off, the LED should turn green. And if the temperature is high and the pet is there, so the fan will be turned on, and then what we will say is that the LED will turn red, showing that the temperature is high and the fan is on. I hope so this is very clear to all of you, that what is the objective of the project that we need. Okay, now to see the presence of any pet, we will be using the PIR sensor. Okay, so if you remember, PIR sensor is something that we have already worked with, and the full form for PIR is passive infrared sensor. Okay, now what does passive over here refers to? Passive refers over here that it is not emitting any infrared radiation, rather it is waiting for an external infrared radiation to be sensed, and once it sensed, it assumes that someone is coming in front of it, and then it says that motion is detected. Okay, I hope so this is clear, right? And therefore PIR sensor effectively works in cases where the object emit heat, because IR radiation or infrared radiation is actually emitted from objects which are heated up, which are warm objects like human body or animal body or any hot objects. Okay, I believe this is clear. Now talking about the pins once again, so PIR sensor comes with 3 pins. One is ground and the other is power, to power it up, and then third pin is signal pin, and this basically gives us a digital signal. Okay, it gives us a digital signal. Now from this digital signal, now we know that digital signal can be either of two. It can be either 1 or it can be 0, right? So I'll say that what would happen if we get a digital value 1? If we get the digital value 1, it means that motion is detected. If we get the digital value as 1, we will say that motion is detected. Okay, and if the signal pin releases 0, okay, which means it releases nothing, right? So in that case what we'll say is motion is not detected. Motion is not detected. Okay, so this digital signal will tell us whether the motion is detected or not. 1, the motion is there. If 0, the motion is not there. Okay, so this is how we will be using the PIR sensor. Okay, moving ahead to the next part. Then we have the temperature sensor. This temperature sensor will actually sense the temperature and tell us that what is the environmental temperature. Okay, and based on that we will be using we will be doing some conditional statements to see what action we need to do according to the temperature and the presence of the pet. Okay, now if you look over here, temperature sensor, the series name of this temperature sensor is TMP36, and it also has 3 pins. We have ground, we have power, and the center pin or the center terminal is the V out. So basically the power pin will take 5 volt. Ground will be actually the negative terminal, so current will move from power to ground, and based on whatever the temperature is there in the environment, it will release out certain voltage value. For higher the heat, the higher the voltage value. The lower the heat, the lower the voltage value, and based on that we can sense what is the temperature in the surrounding. I hope so this is clear, right? Now the V out pin actually gives us analog signal. Why? Because it can be anything between a certain range. Okay, it can be anything between a certain range, and therefore we will be sensing it from the analog pins. Okay, I hope so this is again clear. So this is the temperature sensor TMP36 that we are going to use in our today's session. Okay, now these two components we have already learned in our previous session. The next two is something that we are going to use for the first time. Okay, but they are very simple, since now you might have understand about many stuff in Arduino programming. So learning a new component now will be super easy for you. As I've already mentioned, whenever you try to use any new component, you need to ask yourself two questions: what it is used for and what are the pins for. Okay, so first of all we are going to talk about the DC motor. This is one of the most common motors that we kids always play, right? If you have a broken toy car or remote control car, or you can just buy it from the stationery, that toy will have a rotationary component. That rotationary component is nothing but the DC motor. Okay, now when we talk about DC motor, the sole purpose of DC motor is rotation. So basically its axle will rotate, and you can add something to this axle so to make that object also rotate around an axis. Okay, now for its operation, for its proper operation, you will need to have two pins connected. Now we have two pins. The first pin is power, and usually power is connected to 5 volt. Usually power is connected to 5 volt, and ground is nothing but the negative terminal, and likewise the circuit will be completed. Okay, now when you supply the power to this DC motor, you will see that this DC motor's axle will move. Okay, and we'll see this in the practical part. Okay, this will move, and once it is moving, we'll see that it will display a number followed by written RPM. For example, it will be mentioned over here 556 RPM. Now what does this mean? 556 RPM means that it will rotate 556 times in 1 minute, which means that RPM stands for rotation per minute. It refers to rotation per minute. Okay, so if you, for example, if you connect a resistor and then lower the voltage which is supplied over here, the DC motor will rotate slowly, so the RPM will go down. But if you supply 5 volt power supply, right, in that case what will happen is it will rotate in its max potential. Okay, so based on varied voltages that you are supplying to this DC motor, you can change the speed of the rotation also, and this can be a very important point when you want to create remote control cars, and you can control the speed of the remote control cars using these concepts. Okay, so the DC motor over here, I believe this is clear to all of you. Okay, moving ahead to the next thing is RGB LED. Now this is a special LED that we are going to use in today's session. Rather than having two different LED to show red color and green color, we are going to use only one LED which has all the colors. Okay, and because it has all the color, the number of terminals that we have is also more. Each terminal will be controlling different colors. Okay, so if you see over here, we have a total of 4 terminals in this LED, and we have 3 colored terminals. Okay, for example, we have one for R, then the other for G, and then the other for B. Red, green, blue, RGB. And with the combination of these 3, we can create any color that we want to. Okay, by changing the variation of saturation of every color, we can get any other colors that we want to have. Okay, and then the final one is cathode. Let's try to understand that how it actually works. So basically what we will do is we will connect all the color pin to a digital pin. So we have, let's say for example, digital pin 11, then we have for green we'll connect it to digital pin 12, and for blue color we'll connect it to digital pin 13. Right, now once it is connected to the digital pin of the Arduino board, then we can control each single individual pins and determine whether we want to pass current to it or not, right? So if let's say for example if I am passing current in digital pin number 12, then the current will go in this terminal, the circuit will be completed, and the current will come out from the cathode and go to ground. It will connect to ground, okay, and therefore the color that it will emit will basically be green. However, if you turn off the digital pin number 12 and then turn on digital pin number 11, so what will happen is now the current will not flow from here, but the current will flow from digital pin number 11, and then the circuit will complete and the current will come out from the cathode and go to the ground connection, okay. So this is how for every wire that we have, we will be getting different colors, okay, and that's how we can control what color we want to have, okay. Now you can also do this thing, that if you pass current in digital pin number 11 and digital pin number 12 both at the same time, the resultant color of this LED will be a combination of both green and blue, which will be somewhere yellowish color, okay. I believe this is clear to all of you, right? So that's how we can create any other color by combination of all of these three colors, and we can if we for example connect it to analog pins, then we can also change the voltage, and then we can control that how much of red and how much of green, how much of blue we want to create different kinds of combination of colors, okay. I believe this is again clear. Moving ahead, so here is our objective. If you see, these are the 4 things that we are going to use in today's session, and we are going to learn that how to program and interface with many sensors and many actuators together. So here's a quick question for all of you. Tell me in the chat section that how many actuators we have in this project and how many sensors we have in this project. So actuator can be said as A, and you can write A dash the number, comma, and then we have sensors, so you can write S dash and then the number. Let me see that how many of you are completely aware that what actuators are and what sensors are, okay. So I'm leaving it up to you. So once again if you look at the diagram over here, this is the project that we are going to create in today's session, and the thing is, the very first thing that we are going to talk about is temperature sensor. So this is TMP36. TMP36, if you see, we have and throughout the project I have made the one thing consistent, that red wires are connected to power pins and the black wires are connected to the ground pins, okay, so that we are not confused what red and black are. Then the other colors are connected for signals, okay, fine. So if you see in temperature sensor, we have red wire connected to 5 voltage and then black wire connected to the ground of the Arduino board, okay. Then this way the temperature sensor will be functional, it will start working, okay. However, once it starts working, it will sense the temperature, and we want to know that how much temperature it is. So we will get that from the signal pin. The signal pin is connected to A1, and make sure that you remember this, okay. A1 is for signal pin, okay. I'll just write it over here. A1 is the temperature pin, okay. I believe this is clear, okay. A1 is a temperature pin. Now guys, tell me whether we are going to use input over here or output. Is A1 an input or an output? So we need to see, are we sending the values or the signal from A1 to the sensor, or are we getting the value or the signal from the sensor to the Arduino board? It is the second one, where we are getting the Arduino board is getting the value from the sensor, and therefore this will be considered as an input, okay. It will be considered as input, okay. It will be considered as input. So this is the first thing that we understood. Second connection, we will be checking the PIR sensor. So PIR sensor over here, again for its operation we will be connecting the power pins. So the power pin, we have the 5 volt and ground connected to 5 volt and ground, and then we have signal pin. Now we have already decided this, that PIR sensor actually outputs digital signal, either yes or no, right, and therefore we are connecting the signal pin to a digital pin. Here the temperature sensor signal pin was connected to analog because it can give us any value which can be in between, but not in case of PIR sensor. Okay, so PIR sensor will send signal, a digital signal over here connected to pin number 3. So I'll say pin number 3 we have PIR pin, and this can be again input. Now because we are getting inputs in pin number 3 and pin number A1, the components connected to that specific wire are actually sensors. Why they are called as sensors? Because they're sensing something in the environment and giving us the data in the Arduino board. So they are basically the input components for us. Okay, now moving ahead to the next part, we have the LED. Okay, now this LED to control two different colors, because we wanted green color as well as red color. So I'll be connecting two wires, one in the red terminal and the other one in the green terminal, and then I'll connect the cathode with the ground terminal. Okay, with the ground. Now to ensure that a lot of current is not passed through the LED, I will be connecting a 1k ohm resistor in between the ground connection. Okay, so that it gets the necessary amount of current, not too much. Okay, so here we are using pin number 11 and pin number 12 for green color and red color respectively. Okay, so we have pin number 11 and pin number 12. Let me erase this. Okay, pin number 11 and pin number 12. So pin number 11 is actually connected for green, so we have green LED, and then we have pin number 12 red LED. Okay, this will be actually an output and this will be actually an output, and it's very good practice of writing this down when you're planning a project before starting the programming aspect. Okay, so that you're not confused when you're writing the program. Okay, the last and the final pin that we are going to use is the motor pin, and motor pin is connected to pin number 13. So we'll say pin number 13 will be motor pin, and because we are passing current in case of motor, so we'll say that this also will be output. So basically we have 3 input and 3 output pins. So we have 2 input and 3 output pins. Okay, I believe this is clear to all of you, right? Okay, so 2 inputs and 3 output pins. Okay, and this is something that you will see in the project. Okay, now what we will do is we will be learning a new concept of coding before we move ahead. Okay, the new concept is the AND operator. The AND operator looks something like this, and it checks that if 2 conditions are satisfied or not. In our case, what happens is the 2 condition is that if the temperature sensor is more than 30 degree, if the temperature sensor senses a temperature of more than 30 degree, and if the PIR sensor senses the motion, only if when these 2 conditions are met is when we want to toggle the state of the motor and the LED. Okay, we want to toggle means if it is this, then it will turn to the other thing. Okay, fine. So we will be using AND. Now AND actually checks 2 conditions at the same time, and only if both the conditions are true is when you get the result true. Let me explain you this with a table. Okay, so let's say that we have 2 things. We have over here the temperature, and then we have the motion sensor. Okay, and then here we'll say result. Now what are the different cases that we can get? Okay, either the temperature can be high, and the motion is there, so I'll say motion is yes, or the temperature can be high and motion is not there, or the temperature can be below the threshold value but the motion is there, or the temperature is below the threshold value but the motion is not there. So there are total 4 cases which can happen. Okay, 4 cases, 2 cases of temperature and then 2 cases of motion. We have a product of all of these 2 2s are total 4. Okay, now what should be the result? If the temperature is high and motion is there, It means that the pet is there and the temperature is very high, which means that we want to change the state. So this is true. Okay, the next thing is, if the temperature is high but the motion is not there, which means the pet is not over there, so does that make sense to turn on the fan even if there is no one there? No, right? So we'll say false over here. We don't want the fan to be turned on. Then we have low temperature and motion is there. Now low temperature is there and motion is there. Do we want to turn on the fan? No. So we'll say again false. Then we have low temperature and no motion at all. The temperature is also fine and the pet is also not there. So does that make sense to turn on the fan? No. So again we'll say false. So the only case where we want the fan to be turned on is when the temperature is high and the motion is there. I hope this is clear to all of you. And to see two conditions at the same time, we will be using the AND operator. We will be using the AND operator inside the conditional statement. Okay, I believe this is clear to all of you. Since I have already explained the most of the aspect of the program, we will be moving to the project now. Okay. All right. So let's move ahead. We will be going to our project. So here is our project, and as I've already mentioned in the PPT, the same thing is over here. Okay. Now let's dive into the program. Okay. I'll click on code, and if you see, I have created some variables, and all of these variables are actually storing the pin numbers where the pins are actually connected or where the sensors are actually connected. Okay. So if you remember, the temperature pin was connected to A1, the PIR sensor pin was connected to pin number 3, the green pin of the LED was connected to pin number 11, the red pin of the LED was connected to pin number 12, and the motor pin was connected to pin number 13. So now we have stored all of these pin values inside a variable. Now why are we storing this inside a variable? Because if we make any changes, all we need to do is just make the change in that specific variable, and that change will reflect in all the other places wherever we are referencing that variable. Okay. Moving on to the next part is, I have initiated a few more variables which will store some values. For example, we have temperature value, and then we have mapped temperature value. If you remember in the previous sessions, the temperature value that we will be getting is actually voltage value, but not the value in degrees Celsius. So we need to use a map function to convert that voltage value into degrees Celsius. So we will be storing that in map temperature value. And then the final thing is PIR value. PIR value will store whether the motion is sensed by the PIR sensor or not. So it will be either high or low. Okay. Now inside void setup, if you see, we are setting all the pin modes. And as I've already mentioned, 2 pin modes will be of type input and 3 pin modes will be of type output. I guess this is very clear to all of you. I don't need to spend too much time in explaining this, right? Moving ahead. Then, because that was in void setup, that code will run only once, and then we have void loop. Now everything that you will be writing inside void loop will repeat again and again. It will repeat again and again. And therefore, if you see over here, the very first thing that we're going to do is, we are going to store the value of the temperature inside the temp val variable. So inside the temp val variable, we are going to do analog read. Why analog read? Because temperature sensor is connected to the analog pin. So make sure that you're using the correct function. What kind of signal are you talking about, and what kind of action are you talking about? Here we are talking about analog signal, and we want to read the signal. We want to get the signal. Okay. So here rather than writing A1, I am going to write temp pin, because A1 is stored inside temp pin. Okay. And once we get this value, we will be mapping it using a map function. So map temp value, will be putting this value inside temp value, and then the maximum, this is from maximum from minimum to maximum to minimum, right? So this is the range that I am getting, and I want to change this range into this range. Okay. So this is from maximum from minimum to maximum to minimum. Okay. So I want to change 358 to 125, 20 to -40, and everything in between. Okay. Once that is done, then I will also sense whether the motion is detected or not. So for this I'll be using this variable PIR val, and in this PIR val I will store the value coming from the PIR pin, right? So it will basically sense the value and it will store it inside PIR val. So the value that it will store inside PIR val will be either high or low. High if the motion is there, low if the motion is not there. And the reason that we are using digital pin, digital read, is because digital pin is connected in the PIR sensor. I believe this is clear to all of you, right? Let me remove this wire. Okay, moving ahead. Now since we have gathered all the information from the sensors, now it's time to check what are we supposed to do and take decisions. Okay, the very first decision statement that we are going to use is an if statement, and if you see in this if statement there are two conditions. The first condition is here, then we have and then the second condition is over here. So let's talk about that. If the map temperature value is greater than 30, if the temperature is greater than 30 and at the same time the PIR value is equal to high, which means that the motion is sensed. This means that if the temperature is higher than the threshold and the pet is over there, it means that this is an alarming state. And if this is an alarming state, we will do three stuff. First, we will turn on the fan. Second, we will turn on the red LED. Third, we will turn off the green LED. Okay, so let's see all of these three things happening. So I'm going to say digital write red pin. Red pin will be set to high, which means that red pin will turn on. Then we have digital write green pin low, which means that green pin will turn off. Okay, and then we'll have digital write motor pin high, which means that motor pin will turn on. Likewise, if this is not the case, and we have already discussed about this, right, that only in this case we want the toggling to happen, not in the other cases. Not here in the other cases we want that to happen, isn't it, right? And therefore what we are going to do is we are going to write all the other things inside else. If this happens is when we want the motor to turn on, we want the red LED to blink, we want the green LED to turn off. However, if that doesn't happen, then everything will toggle. Toggle means the things which are on will be off, the things which are off will be on. In this case, what will happen is red pin will be turned off, green pin will be high, which means it will turn on, and motor pin will be turned off. All of that will happen, and then it will wait for 1 second for the same thing to repeat once again. Okay, and this thing will keep on happening again and again, till the time the power is supplied to your project. So let's test it out. Are you all ready, guys? I'll click on start simulation and then I click on close the code, and here what I'm gonna do is, let's have enough space. So let's say that this is your pet house over here. Okay, this is your pet house. Now right in front of your pet house, this temperature sensor will sense the temperature. Okay, let's assume that the temperature right now is 25. I have set the temperature to 25 right now, which is below the threshold value. Okay, and then let's say that this ball over here is actually your pet. Now if your pet is moving here, you will see that nothing is happening. The RPM value of the DC motor is 0, which means that it's not rotating. And even if you look at this LED also, you will see that the green LED is brighten up. It means that things are fine. There is nothing wrong. Okay. Now what I'll do is I will increase the temperature. Now the temperature is set to 85 degrees Celsius, which is tremendous amount of heat energy. Okay. Now in this case what will happen is, right now again the LED is green and the fan is stopped, right, which means that again nothing will happen. Why? Because the motion is not being sensed, and because motion is not being sensed, the project is assuming that the pet is not there. Okay. However, the moment you start moving the pet, the moment the pet starts moving, the temperature was high and the movement was there, and therefore your LED will turn red and the fan will turn on automatically. You don't need to control that at all. The moment your pet moves out of the range is when, now if he is out of the range, now if you look over here, though the animal or the pet is moving, it is not within the range of the PIR sensor, the fan and the LED has turned off, which means that not only it is taking care of your pet, but it is also taking care of wastage of electricity also. The moment it comes within the range, again if the temperature is high, the LED will turn red and the motor will turn on. So that's how wonderful project it is, right? And you can actually get all of these physical device at your home, make the connections, flash the code, and then install it in your place where your pet is usually living. And this project can truly be very helpful in case where you have some plans to leave your pet at home and go for a trip, especially in this summertime, right? Fine. So that's all about the project. I believe this was clear to all of you. In the description of this video, I will be adding the link of this project so that you can refer to this, and if you would like to make more changes to it, you can just remix it in your own account, and you can start editing as well. Okay, so make sure that you open the description box and go to this link to experiment more with it. Well, thank you so much, dear students. This is everything that I had planned for you. We will be having a quick quiz questions right now, and then we'll end this session. Okay, I want all of you to be interactive with me so that we can finish this quiz question really very quick, and then you can be back to your work once again. Okay, so moving ahead, quiz time. Okay, what is an operator called? What is this operator called over here? Is it OR operator, XOR operator, NOT operator, AND operator? The answer is AND operator, option D. Okay, then moving on to the next question. What would the result of the below statement be? Now we have two values for x and y. The value of x is 3 and the value of y is 5. Now you tell me what would be the answer of this statement. This statement says x is greater than 0 and y is less than 10. Looking at this value, tell me what would be the correct answer. X is greater than 0 and y is equal to 10. And in order to do this, to make things really very simple, you can see what is the truth value for each given statement. So we have two statements over here. Let's talk about the first statement. The first statement, x is greater than 0. Let's see the value of x. Is the value of x greater than 0? Yes, 3 is greater than 0, which means that this value is true over here. Okay, moving to the next statement. This says that y is less than 10. Let's see the value of y. The value of y is 5, and is that less than 10? Yes, it is. So this is also true, and we have learned this that when we talk about and will be true only if both the conditions are true, and because both of these two conditions are true, the result will also be what? It will be true, and therefore your correct answer will be A, true. If either of these values are false, then your AND value will be false. Okay, moving ahead. Last question for today. Why do we use resistor in the circuit? This is a very basic question. We have learned this in the very first class of our series, right? So why do we use resistors in the circuit? To reduce the current flowing, to reduce a voltage across 2 points, both A and B, or none of these. So well, the correct answer is actually both A and B, because this is actually governed by the Ohm's law. Ohm's law says that if the voltage is decreased, the current will decrease at the same time. So both will come down or both will go up. And with the introduction of resistor, the voltage will go down and at the same time current will be less. Okay, and therefore both A and B is true in this case. Well, thank you so much for joining this session, guys, and this series is now about to be ended. However, I would like to congratulate all of you to be with me for this series of 6 days where we have learned to create several projects and we understood the basic functionalities and basic aspects of robotics. Using all of these concepts, we can create n number of projects. The imagination is only the limit, right? Stay with us. Make sure that you subscribe to our channel so that these kind of new series is something that you will get notified about. Okay, so with this, I would really like to congratulate all of you. You have become the master of Arduino programming right now, Okay, well, make sure that you also download our sisyaclass app, because there you can see more courses that we have to offer, where our top teachers from NIT and IIT are there to help you in various subjects. So make sure that you join this join this channel and subscribe this channel, and at the same time you also download the sisyaclass app from the App Store and the Play Store. And don't forget to like and share this video also to your friends and family, so that they can also get the benefit out of this video. Well, thank you so much. It was wonderful having this session with you and this series. We wish you all the best and keep coming back over here. Tata, bye bye.